Wow, there's quite a bit going on here on this table now, huh? This is actually a little bit of an update from my cloning wild mushrooms onto agar video I did, what, 2.5 months ago or so? As you can see, quite a bit has happened since then. Let's just start with these guys. These are the aborted form of the Entoloma abortivum. And this right here, this is actually a transfer that I did from one of the original petri dishes that I inoculated with tissue sample. Same goes with this one, and same goes with this one. These are all tissue transfers that were from, I think it was this one right here. Yeah, you can see right there where I took some of the tissue, some of the mycelium from this guy, and I used it to inoculate these petri dishes right here. And as you can see, things are actually going really, really well. But there's something I wanted to show you with these aborted Entoloma, which I think at least are really, really interesting. This is one of the original untouched petri dishes that I inoculated with tissue sample from the mushroom itself. I just let this in my incubator until it fully colonized. And now, look at that right there. The aborted form of the Entoloma abortivum has put off these nodules that look like miniature versions of the Entoloma abortivum of shrimp of the woods. And this isn't a one-off. Here is another one. Again, this is another one of the original ones that I inoculated straight with the mushroom tissue. I don't know if you can see all that great because of the condensation on the top here, but there is another nodule on this guy that looks like an aborted form of the Entoloma abortivum. So that is really, really cool. But there's something even cooler, I think at least, to talk about here. First of all, we'll just go to this stack of petri dishes right here. Here is one of the original petri dishes that I inoculated with the fully formed fruit body of the Entoloma abortivum. And you can see that I've been using this to take quite a few tissue samples for inoculating onto other culture plates. Here's another one. Same deal. I use this one to inoculate quite a few culture plates and different grow media and different substrate to see what it liked to grow best on. And this is one of the original ones too that I inoculated with the mushroom fruit body tissue sample. Looks great. The growth is fantastic. It's actually grown very, very three-dimensionally. Usually mushroom mycelium grows fairly flat along the surface of the agar, but this one grew very, very up, and it actually squished itself against the top of the petri dish, which I just think is pretty neat. But this is the point I wanted to make, and you probably already saw it down here. This is one of the original petri dishes from the fully developed Entoloma abortivum mushrooms, the mushroom fruit body. And look, the fully developed tissue sample is also by itself. There's no honey mushroom or armillaria tissue in this sample whatsoever. It is also putting off these aborted nodules. Like I said, this is from the fully developed fruit body. This one right here, let me get this petri dish. This one right here doesn't surprise me too much to see these odd areas of growth because this is from the aborted form. But this is from a fully formed Entoloma specimen. So does that mean that it's actually fairly common for this species to just put off these aborted mycelial masses? Or am I missing something here? Because like I said, there's no honey mushrooms in here for them to interact with, yet they still seem to be very, very apt at putting off these aborted nodules of mycelial growth. Very strange. And I can show you another one here. This is actually a culture slant that I was just kind of playing around with. I'm fairly sure, I forgot to mark whether this was the fully developed or if this was the aborted form of the Entoloma, but I'm fairly sure. Where's it at? Hold on. Yeah, I'm almost positive it came from the middle of this guy right here, because in this petri dish with the fully developed Entoloma tissue sample, I noticed that there was another one of those nodules that looked like a shrimp of the woods. And I used that to inoculate this culture slant down here. And while unfortunately it did, I don't know how well that's coming through on camera. And you can see right here, there's I think that's yeast. Like a small yeast contamination down the side. I think they actually got in because this aluminum wasn't making a great seal around the top, and it probably let some stuff in, then it rolled down the side. But it's actually not that big of a deal because you can clearly see that this is doing really, really well. And this culture slant has both the aborted Entoloma, weird shrimp of the woods nodule looking growth right here, and right here. But at the bottom down here, it also has, these almost look like what I would expect mushroom pins for this species to look like. Look at that. And look at that nice rhizomorphic mycelial growth right there going to these little mushroom pins. That's pretty cool. So yeah, like even the fully developed form of the Entoloma seems to put off the aborted forms of their fruit bodies fairly commonly without any real influence from the honey mushroom, at least here in my lab setting. So yeah, that's something that I kind of want to mess around with, which is why you can see right down here in the middle are some petri dishes that I just inoculated today. These are 4 I won't show you all of them because they're all exactly the same, except for the spacing of the tissue samples. But these are 4 mushroom samples taken from the aborted form of the Entoloma abortivum and some of the honey mushroom, the Armillaria tissue sample, put on the same culture plates. So we have Entoloma tissue sample here and honey mushroom tissue sample there. And I just kind of drew a line on the bottom here of the petri dish, and I labeled which was which on the bottom so that I could keep track of which is which easier. And I also used pure light malt extract for these petri dishes just so that it was nice and clear, so it was easier to see the growth and the interaction, hopefully. I want to let these incubate for a while and see what happens whenever the 2 of them grow out and then finally meet each other in a controlled environment here in my incubator. And I just want to see what they look like whenever they kind of run into each other and encounter each other. So yeah, like I said, these are all the same except for the spacing of the tissue samples. So keep an eye out for this video, because once this does anything, I'll probably make an update to show you what that looks like. And here on this little corner, we have 2 of the Hericium petri dishes that I took from that Hericium. I'm almost fairly sure that was a bear's head tooth mushroom that I found. Yeah, these are 2 of the really beautiful culture plates that turned out absolutely perfectly from that tissue sample. I had 4. I started out with 4. Now I have these 2 because I used the other 2 to inoculate some sawdust, and I'm just kind of letting that colonize right now to see what happens. But I kept these just to have in my culture collection, and probably once the weather gets a little bit warmer, I will use these to make more culture plates, more petri dishes. These turned out fantastic. And right here is a really small 50 milliliter Erlenmeyer flask that is filled with sawdust and coffee grounds. And I inoculated this today at the same time that I did these guys right here. I inoculated this with the Entoloma tissue sample to see what it would look like growing on coffee grounds and wood chips. And then I kind of want to, after this colonizes completely, I want to open up the top and see if they actually fruit from the top and what form they would fruit in, to see if it's an actual Entoloma fully developed mushroom or if it's like an aborted form of the Entoloma. So this is going to take a while, so I'll let you know what happens to this eventually. This is a fully colonized 90 millimeter petri dish of the Entoloma fungal tissue. This is the fully developed one. I have it written there underneath this parafilm. This is going to go right into my refrigerator for my culture collection. So that's the main reason why this was inoculated. I just wanted to keep this one as a bulk sample for my culture collection. Here are all of the honey mushroom petri dishes. Once again, this is just a really large 90 millimeter petri dish that contains the honey mushroom tissue sample. It's fully colonized. I think you might just be able to make that out underneath the parafilm here and the condensation, which isn't too bad on this one compared to that other one, but still. But this one is for the sole purpose of keeping in my lab fridge for my culture collection. Here are all of the small honey mushroom petri dishes. This was one of the original ones right here. Let's see. Yep, and there's another one of the original ones. And another one of the original ones. I think this may have been one of the original ones too. I did 4. None of them got contaminated. But you can see that it's been quite a while. And the honey mushroom tissue samples look pretty different from one another. But they're all really healthy. They seem to grow very, very slowly compared to other species that I've dealt with here. But they do have a really interesting growth pattern in them. Especially this plate right here. This is really, really cool. In fact, I wish that I I wish that I could have taken a better video of this whenever it was first doing this. But you can see right here in the middle is the initial tissue culture sample that I placed on the Petri dish. And this actually grew out. It started spreading out a little bit, like, you know, just like regular mycelium that you'd be looking out for and what you'd be used to. But this actually started putting off these really, really strong, thick rhizomorphs that dug down into the agar. You can see it here on the underside. It dug down into the agar, it hit the bottom, and then it actually started coming out of the top of the agar. So this thing was like really starting to take off. This is a really good like genetic sample of this Armillaria species, at least as far as like fruiting properties go. And you can see that I took a little chunk out of here. Anytime you see like a square or like a chunk of agar missing, it's because I took a piece of tissue from that Petri dish. This is more what you would expect from a mushroom on agar. Just kind of white mycelial growth. And oh, I guess you can kind of see, yeah. Right here, this one's starting to do it now. I just realized this. You can see right there that this one put off a rhizomorph, which is basically just a really thick string of mycelium that looks a lot like a plant root. And this one actually put a relatively thin one, like down through the center, and it's hit the bottom of the Petri dish. So it looks like this one is starting to do what this guy did. So that's pretty cool. I think I'm going to be doing some experiments with this one just because the genetics are so good. The genetics for this one seem to really like the agar that this is growing on. I'll be doing something with this in the future. Really all I have to say about the honey mushrooms, these two honey mushroom Petri dishes here are just other tissue transfers that I did from the original Petri dishes right here. And they're doing just fine. It just seems that honey mushrooms tend to be a little slower growing than what a lot of other mushroom species are, that's just the way they are. Nothing wrong with that. Now that I say that, I'm still going to grow these out, you know, the ones with the Entoloma and the honey mushrooms on the same plate. But I think maybe instead of putting them on here at the same time, maybe since the honey mushrooms do grow so slowly compared to the Entoloma, maybe I will inoculate the honey mushroom side first, let that colonize for a while, and then I'll put some Entoloma on the other side. That way the Entoloma doesn't overtake the entire Petri dish before this has a chance to do anything. But, you know, I'm still curious to see what this does. So maybe I'll do that, maybe I won't. I don't know. This right here, this glass Petri dish, I just did this today at the same time I did those ones I just showed you. Well, the ones I was just talking about with the two different tissue samples on it. This is a honey mushroom tissue sample that I placed onto some more coffee grounds and sawdust. It's mostly coffee grounds with a little bit of sawdust as filler, and it's the same thing that's in here, except this is an Entoloma and this is a honey mushroom. And right here, this is the same deal, except this is an Entoloma culture sample that I just placed on here as well. I'm looking forward to seeing what these honey mushrooms look like growing on something like this compared to agar. It's going to take a while because they are slow growing, so I just got to be patient with those. I think that's it for the honey mushrooms. So let's move these over here. Now these are the chicken of the woods, the yellow chicken of the woods mushroom samples that I have. And as you can see, these look, this one's a little worse for wear. These are the original ones that I inoculated. I think I just threw one of the other ones away because that one was so heavily contaminated. This may have been the one that I showed how to salvage a Petri dish that's contaminated. So that's why I didn't really worry too much about this one. But you can see, even though that one was very severely contaminated, it still colonized the whole agar before drying up. But, you know, still. And even these ones, which were fairly contaminated at the site of inoculation, they did manage to kind of overcome the contamination issue, overpower it, and then completely colonize these culture plates. So I just wrapped them in graphing tape, and I just put those in my fridge too, just to have. They seem to be fairly resistant to contamination. That's pretty good genetics to have on hand. These guys right here, you can see all the water in there. They're fully colonized. They look great as far as growth goes. But the problem with these two are I took a tissue sample from one of these, I'm pretty sure it was this one right here, and I placed it onto the agar. I placed these into my yogurt maker that I modified to turn into a mushroom, incubator as well. And the problem that I had with that, I had to fix, at least after using it and finding out that I had a problem, was these were sitting directly on the bottom where the heating element was, and the parafilm did its job and it kept the moisture in. but unfortunately, being that close to the heat and like direct contact with the heat source, it completely drove out all of the moisture out of the agar itself and just had it like kind of condense on the top of the culture plate here. I modified it a little bit and I put an insulating piece of styrofoam on the bottom, and then I put some plastic on top of that, and then I put a new petri dish that I inoculated with some yellow chicken of the woods mushrooms. You can see here this one turned out fantastic. This one I'll probably use for experiments and like just kind of playing around with chicken of the woods mushrooms to see what they like to grow on and what I can and can't do out here. And these two larger petri dishes right here are also the same yellow poured chicken of the woods mushrooms that are completely fully colonized on these 90mm petri dishes. These are perfect for my culture collection. So that's where they're going to go. And finally, right here in this last glass petri dish is some of the same substrate that I had in here and in that little Erlenmeyer flask, you know, the coffee and the wood chips. And I have a sample of the yellow poured chicken of the woods mushroom inoculated on here, and it is currently colonizing this as well. So I'd say overall, this was actually a fairly large success. Everything turned out great. I didn't really have a whole lot of issues with these mushrooms. I can't really ask for anything better than this. It was really cool seeing them all grow, especially I really love the way that like chicken of the woods mushrooms look on agar. And my phone's not doing a fantastic job of picking up the color, but this is like a very brilliant orange color. It's a lot different than what I'm used to seeing like with regular white mycelial growth. That being said, these are just really cool to look at too, because you have these white mycelial growth patterns, but then you have these really interesting nodules they just look like shrimp of the woods but miniaturized. So this has actually been a really fun, really cool experiment to watch undergo. I just wish that I had more time to devote to this so that I could kind of do more with you guys and show you guys, but like I always say, I'm always so busy, so I kind of have to do this in my free time, which lately I have had very little. I can't really ask for anything better than this, and hopefully soon I can give you some more updates and show you what is going on further with these guys. But until then, I'll see you guys next time. Thank you for watching. Bye-bye.